Commercial aviation is often touted as one of the safest ways to travel, and statistically, it is. But as airlines expand across the globe, pilots sometimes find themselves flying into airports that don't follow the same design and safety standards seen in the United States or Western Europe. The recent Boeing 737-800 crash at South Korea's Muan International Airport is a sobering case study and a bit of an aviation safety facepalm about how a seemingly small design flaw paired with a bird strike and not enough time for checklists can end in disaster. Grab a coffee because this story involves birds, hydraulics, an ill-placed dirt mound, and a runway landing so unconventional it would make a flight simulator sweat. The trouble with Muan's localizer berm. Instrument landing systems are the unsung heroes of low-visibility approaches. A key part of the instrument landing systems is the localizer antenna, which transmits lateral guidance so pilots can line up with the runway. Normally, these antennas are mounted flush with the ground on a base designed to snap off easily if an aircraft overruns, like an electrical outlet that pops out if you trip on the cord. Muan, however, decided to do something different. Instead of keeping the localizer level with the runway, someone apparently thought, why not pile up a big mound of dirt and stick the antenna on top? And thus, a large, hard-packed berm was built just past the departure end of runway 19, the opposite end of runway 01. Aviation nerds cringed. Safety engineers probably cried. This berm, essentially a man-made speed bump for jetliners, became a deadly obstacle. When the ill-fated Boeing 737-800 hit it during its emergency landing attempt, it tore through the aircraft like a can opener. That mound is a big reason why only 2 people survived, the flight attendants seated in the rear-facing jump seats at the back of the plane. The flight? Routine until it wasn't. The aircraft, a 2009 Boeing 737-800 powered by trusty CFM56 engines, departed Bangkok for a roughly 4.5-hour flight back to South Korea. The weather at Muan was as benign as you could ask for. Light winds, clear skies, great visibility. ADS-B tracking showed the flight making a stable approach to runway 01. Flaps down, descent rates normal, speed around 144 knots. Everything looked like a textbook arrival, until it didn't. At 8:58 a.m. local time, the flight disappeared from public tracking data. 7 minutes later at 9:05 a.m., it crash-landed on the opposite runway heading runway 19, in a chaotic sequence of events that investigators are now trying to piece together. Compressor stall chaos. One of the first signs of trouble was a massive compressor stall on the right engine, engine number 2, during final approach. If you've never heard a compressor stall, imagine a cannon blast mixed with a thunderclap, the result of disrupted airflow through a jet engine. Bird strikes are a common trigger. A bird gets sucked in, the smooth airflow collapses, and the engine basically coughs violently. Bird activity at Muan is well known. It's near the water, after all. And while the control tower reportedly warned the crew, there's only so much a pilot can do when a feathered kamikaze decides to test your fan blades. The right engine likely ingested 1 or more birds, triggering the stall. There's speculation that the left engine might have been affected too, either with bird damage or secondary compressor issues, but we won't know until the flight data recorder is fully analyzed. To make things worse, bird ingestion can fill the cabin or cockpit with smoke as the remains burn in the engine and get recirculated through the air conditioning packs. A grim detail, but true. On the 737-800, the left pack usually feeds the cockpit, while the right pack supplies the cabin. So if the right engine eats a bird, passengers might smell the world's worst barbecue. 7 minutes, 0 time for checklists. From the moment of the stall to impact, the crew had only 7 minutes. In aviation terms, that's no time at all, especially if you're troubleshooting engine damage, possible smoke, and figuring out how to land safely. The 737's hydraulic systems are famously redundant. System A, left engine plus electric pump. System B, right engine plus electric pump. And a standby system. Either A or B alone can fly the airplane. Even if you lose one engine, electric pumps can keep flaps and landing gear functional. But only if you have time to run the checklists, and that's the rub. Flap extension, alternate gear lowering, spoiler deployment, these are not push one button and done tasks. Alternate flap extension is slow. Manual gear deployment involves pulling long cables and following a detailed procedure. The crew dealing with smoke and uncertainty simply didn't have enough minutes to methodically do all of this. Gear up, flaps up, going too fast. Video circulating online shows the 737 approaching runway 19 gear up and flaps retracted, a configuration pilots almost never use for landing. You train for engine failures, hydraulic issues, even partial gear landings in simulators, but not this. Without flaps, the aircraft must fly faster to stay aloft. Without gear, it's sleek and slippery, great for drag racing, terrible for stopping. On top of that, ground effect, a cushion of air under the wings near the runway, caused the jet to float like an oversized sailplane, eating up valuable runway distance. The captain seemed to have full flight control. Hydraulics weren't lost when it lined up neatly. But with no flaps and no gear, the 737 came in hot and long, belly sliding down the asphalt like a 90,000-pound hockey puck. Observers even noticed the right engine's thrust reverser deploying mid-slide, something that normally shouldn't happen until weight is on the wheels. Was it a malfunction triggered by the bird strike? Unknown, but it didn't help. Meanwhile, in the cockpit, one pilot was reportedly seen with hands braced against the windshield as the runway end rushed up, a chilling snapshot of how little time and control they had left. Why the berm made everything worse. Had the aircraft been landing on a standard, obstacle-free overrun area, the belly slide might have been survivable for more people. But that giant localizer berm turned the runway's end into a concrete wall. At nearly 150 miles per hour, the 737 hit the berm just 461 feet past the asphalt's end. The structure tore through the fuselage and contributed massively to the destruction. Only the two aft flight attendants, protected by rear-facing jump seats and harnesses, lived to tell the tale. This is why aviation authorities insist on frangible instrument landing systems, antenna mounts, and clear safety areas beyond runways. You don't turn your localizer into a medieval castle wall. Lessons in design, decision-making, and time pressure. Airport infrastructure, bird strikes, time pressure, and pilot training all played crucial roles in this accident. Even the most advanced airliner is vulnerable if the airport environment is poorly designed, as Muan's hazardous berm turned a bad landing into a catastrophe. Bird strikes, though engines are built to handle them, can still trigger compressor stalls, smoke, and emergencies, especially during short final when options are limited. 7 minutes proved far too little for even experienced crews to fully diagnose failures, run checklists, and configure the aircraft, forcing them into an improvised, unorthodox landing decision under extreme pressure. Finally, the event exposed training gaps. Pilots rarely practice the rare but critical scenario of landing, with no flaps and no gear at high speeds, a challenge that may prompt training programs to prepare for more unthinkable emergencies. What we still don't know. A final accident report will depend heavily on the flight data recorder and cockpit voice recorder to resolve key unknowns. Investigators still need to confirm whether the left engine also suffered a bird strike or a stall, and why the crew neither lowered the landing gear nor used alternate flaps, whether they were simply overwhelmed or facing additional malfunctions. They will also look into whether the right thrust reverser somehow deployed in flight, adding to the chaos and what was said in the cockpit, as the pilots made rapid decisions under extreme time pressure. Until the recorders are analyzed, our understanding remains based on video evidence, DSB tracking data, and system knowledge rather than definitive facts. A tragic reminder with a dash of irony. It's heartbreaking that a preventable airport design flaw played such a big role in this crash. Aviation engineers know how to build breakaway antenna mounts. Safety areas beyond runways are standard in most of the developed world. Yet here we are, talking about a giant dirt mound acting like a medieval battering ram. As one might joke darkly, if you build it, they will crash. Except nobody's laughing in the aftermath. And that's the full breakdown of the Muan 737-800 crash. If you found this deep dive interesting, do me a favor. Hit that like and subscribe. Flying is still the safest way to travel, but understanding what goes wrong makes it even safer. Thanks for watching, stay curious, and I'll see you on the next flight.